Reasoning back to what we said before, the only way for two species to coexist is for them to have slightly different or very different niches, preferably. And in this case, if Jose Verdu goes out and he starts studying a bunch of dung beetles, and they're there, all more or less in good numbers, that is, there isn't like a rare population and then one big population, but there are a number of different populations of species that are in good shape, he should conclude that obviously they don't have the same niche, because for them to coexist, they need different niches. If they had the same niche, eventually one of them would outcompete the others and they would go extinct. Even if they were identical in their ability to compete, by chance one of them would go extinct eventually. So we should be asking ourselves, how are these dung beetles coexisting? What about their niches different? And it turns out it's not what they eat, but what he found, it's when they eat, or it's when they go searching for this dung. And you can see here a plot for 1, 2, 3, 4, 5, 6, 7, 8 species. That's a lot of species to be in one general area looking for the same resource. But the very cool thing about this is how well they've divided up the time that they look for this same resource. So what he measured was when beetles were out and the air temperature. And it's giving you an idea basically of time of day, because we know that, in the morning it's very cool before the sun comes out. So this is morning time, morning, with low air temperatures. And then by the afternoon, we've got a warming environment. And so what he did was he went out all day long and he caught dung beetles and said, okay, it's this species. I take its temperature, I take the air temperature, and I say, oh, it's out when it's 34, okay, and it's up here. Or, oh, it's out when it's 19, and that's down here. But what you could see is each species has a really nice tight distribution. So this species is mainly active between 17 and 23. This species is mainly active between 21 and 26. And there's only a little bit of overlap between when these species are active. And that's the same thing as you go down this line. You can see the whole thing shifts to the right in the distribution of temperatures that they fly at. And what that means is there are species that specialize in finding dung that's late in the morning. And there are species that specialize in finding dung that's late in the afternoon. Basically, they're looking for animals that are pooping at different times of day. And that's how they coexist. And I'm not saying that there isn't a best time to find dung. There probably is. I mean, everyone has a time of day when they like to go to the bathroom. And that's probably true for the herbivores that walk around this place laying massive piles of dung. But if that's the case, you'd imagine that only 1 or 2 species are going to be able to fly at that time, and the rest, who are inferior competitors, are going to end up flying at other times. And what they're doing is eking out a living, making an existence out of those times that the dominant competitors don't fly for dung. And so that whole thing over the course of a day allows many species of dung beetles to get the job done and to survive in this environment. So if you're following along, you should be able to answer this true or false question. True or false, if species compete for many generations, natural selection would cause their niches to diverge.